Today we're going to cover section 4 of chapter 5. It's going to be on isosceles and equilateral triangles. So before we can begin even talking about any of the theorems for these, let's identify the different parts of an isosceles triangle. So the top angle is called the vertex angle. And it's going to be the angle that's different out of the three angles of the triangle. The two bottom angles, and they don't necessarily have to be sitting on the bottom, but the two angles that are congruent are called the base angles. Those base angles are going to be opposite of the legs. The legs in an isosceles triangle are going to be the congruent sides. So the angles that are congruent are going to be across from the congruent sides, which are called the legs. And again, your isosceles triangle could be positioned like this, and the base angles would be up top. Just know that the two angles that are the same are called the base angles, even though it doesn't sit on its base always. And then this would be the vertex angle. So these would be both the base angles, and again, they don't have to sit on their base. So the legs are always the congruent sides, and then your base is going to be the side that's different. Okay, now we're going to see a theorem based on this information, and it's the base angles theorem, and that states that if two sides of a triangle are congruent, then the angles opposite them are congruent. So in this picture, notice we have sides A, B with a congruency mark is congruent to AC. So that means that the angles across from them, angle C and angle B, are the base angles, and they're going to be congruent. So now we're going to do the converse of the base angles theorem. Remember, the converse is where we switch the order. So now they're going to say if the two angles of the triangle are congruent, then the sides opposite those angles are congruent. So this time they're going to start out by giving us that these base angles are congruent. So from there we can conclude that the sides across from them are also going to be congruent. So if angle C is congruent to angle B, then that tells me then side AB is congruent to side AC. So we're switching the order. So now we're going to have some corollaries based off of the base angles theorem and its converse. Remember, these are based off of a theorem. So the corollary to the base angles theorem is if the triangle is equilateral, then it's equiangular. And then the converse to the corollary to the converse of the base angles is if a triangle is equiangular, then it's equilateral. So this is sort of common sense. If you have three sides the same, then we're going to have three angles that are the same, and each angle would be 60 degrees. All right, so it wants us to find the value of x. So we're going to be applying the two theorems we just learned, the base angles theorem and its converse, and then we'll also be applying those corollaries. All right, so in the first example, example A, notice I have two sides that are marked as congruent. So this tells me I'm dealing with an isosceles triangle. I also can realize that if I have two congruent sides, then that tells me my two base angles are going to be congruent. I can apply my triangle sum theorem, and I can see that the three angles of the triangle are going to be adding up to 180 degrees. So if this angle is x, so is this one. So you can do two things here. You could either set it up algebraically that x plus 30 equals 180. Add your x's. Subtract 30. 2x equals 150. Divide by 2. And each one of these base angles is going to be 75. So this one's 75 degrees, which would also make this one 75 degrees. Now, I don't really necessarily, it didn't ask you to write an equation. So technically you could have just done 180 minus 30, gotten the 150, and then divide it by 2. But if you're asked to write an algebraic equation, that's how you would set it up using your triangle sum theorem. Let's try example B. So over here, it wants me to find the value of x. So again, this time, we've got the two base angles marked as congruent. So then that tells me that the sides opposite them are going to be congruent. So over here, that would make that one the same as this one. Now, this number over here, this expression, is here to confuse you. We will not be using that. All we need to do is set 2x minus 4 equal to x plus 5. I'm going to group my x's together, so I'm going to move the x to the left and then move the 4 to the right. So the value of x is 9. If they were to ask you how long the side is, you would be doing 9 plus 5, get 14. One way you could check to see if you've done it right. Remember, once you plug this in, you should be getting 14. So 2 times 9, 9 and 9 is 18, minus 4 is 14. So these two numbers should end up being the same. But the question only asks you to find x, so you could have stopped here and said x equals 9. Now for the next one, again, we need to figure out what that missing angle is before we can figure out, is x going to be the same as the 41 or is it the same as the 42? So let's find the missing angle first by adding the two angles we have. So we're going to add 56 plus 62. I get 118. I'm going to subtract that from 180 because that's what the three angles should add up to be. And the missing angle in my triangle is 62 degrees, making this side, so here are the base angles, so the two congruent sides are this one and this one, making x equal to 42. Yes. Pretty good?
Corey,
Yes.
would this theorem not work on a scaling triangle because there's no congruent sides?
Correct.
Okay, thank you.
You're welcome. All right, everybody good? Let's try example 2. Now, this one, they're giving us the statements for our proof on example 2. We've got to put them in the correct order and then come up with the reasons. So basically, we're writing a proof, but they've given us the statements. We just got to organize them. So here is our figure. So it wants us to place the statements in an appropriate order for a proof and provide reasons. So here is my given information. So that's going to tell me right away that this one down here is going to be number 1. So let me go ahead and I'll make up my proof over here. So I have my statement column and my reason column. Number 1 is angle 1 is congruent to angle 2. and that reason is given. So let me go ahead and add in some markings in here so we can sort of see what we're trying to get to. So 1 and 2 are congruent, so I can add some congruency marks here. Now, also look, see the last statement here? Prove that OK is congruent to OJ. This is going to be the last thing. So there's only 4 of them. So automatically I'm going to see that that's going to be number 4. So now I just have to figure out which one I'm going to put in first, either A or B. So I can see here that I've got some vertical angles going on. So I could say that angle 1 is congruent to 3 because they're vertical angles, which then would also make 2 congruent to 4. So that's going to be my next statement, is that angle 2 is congruent to angle 4 and angle 3 is congruent to angle 1. And that's the vertical angles congruency theorem. You can abbreviate that as VAT. And now I can use my substitution or my transitive. Let's see, I'm actually going to do substitution on this one. So then my next statement is going to be, so this one's number 2, so this one's number 3. So for number 3, angle 3 is congruent to angle 4, and that's substitution. Because what I've done is I've taken angle, I'm taking angle 2 out, and I've substituted it in. So see how these two are equal to each other? And then we can substitute. And then lastly, because these two angles are congruent, I can use my base angles converse and say that this side is congruent to this side. So I can say that OK is congruent to OJ, and that's by my base angles theorem converse. Okay, make sure if it's the converse you stated in there. If you just would have said base angles theorem, you would get it wrong. Okay, but it's the converse here because we're gotten the base angles that are congruent, so there we can show that the sides are congruent. Let's do one more proof. This chapter will be full of proofs, so make sure you're doing a lot of practice. When you're doing your homework, do not leave the proofs blank. I want you to at least attempt it. You should be setting up the columns, you should be putting in your given, and you should at least try to get some statements in between, and then at least have your last statement as what you're trying to prove. We are now in quarter 2. Remember, you must show work for your questions, especially when you're, writing equations and finding missing angles. When I graded homework yesterday on the equations, many of you just had the equations. You did not have any of the work of how you found that y-intercept. So if you're not showing work, you're not going to be getting hundreds for your homework. It is based on completion, not accuracy, but if there's no work to back up your answers, then you're going to get it wrong. Because I do realize you've got the app, you've got the answers. You also have that file I gave you. So if all you're doing is copying answers from that file to your homework, you're going to be getting really low grades for homework. And when you get bad grades in homework, even though it's a small percentage in an honors class, it still brings down your average. So make sure you are showing work for all homework problems if you want that full credit. All right, let's do one more example, and then I'll work out any of the 5-3 homework you want to see, because we may have time here. All right, so again, when you're doing a proof in the homework, put in the given. At least get this thing set up. So I'm going to have a statement column and a reason column. We always write 2-column proofs. So I'm going to restate my given. So I'm going to state that M is the midpoint. Of AB, and that the measure of angle 1 equals the measure of angle 2. I'm going to put both of my given together. Now I'm going to go ahead and add this given to my picture so I can show here that 1 and 2 are congruent. And then I can also put here that M's the midpoint. And I know a midpoint makes 2 congruent pieces. Now, what I'm going to do next is, before I forget that I know I just labeled my picture, in my proof, I'm going to state what I just labeled. And I'm going to state that AM is equal to MB. And that reason is definition of midpoint. Now, remember, our goal here is to get AC equaling MB. So now what I can do is bring in what I just learned, my base angles converse. And because angles 1 and 2 are congruent, then that tells me that side AC is congruent to AM. But notice it's already got a mark, so I'm going to change that to a black one over here. So now I can say that AC equals AM, and that reason is the base angles theorem converse. And now I can do a transitive or a substitution and say that AC equals MB. Which is what they were asking me to prove. And that reason is either transitive or substitution. See how these two simplify or cancel out? So the reason here is either transitive, or I would also accept substitution.
Miss Tori,
Yes.
if you were to use congruent signs instead of equal signs, would it be the same thing?
Yes.
Okay, and then also, is it base angles converse theorem or base angles theorem converse?
It doesn't matter, as long as you got the word converse in there. So let's see, how did it state on the slide? Let's look. Okay, so that is it for the 5-4 notes. You do have an assignment due Monday. I've also posted a quiz review. Now, what I'm probably going to do on Monday is have you work on it in class on Monday. And then on Monday, I'll give you details about your quiz because the quiz is Tuesday. And it'll cover sections 5-1, 2, 3, and 4. So we have about 3 minutes here. Are there any